Okay, we are on lesson 2, and we want to talk about the refrigeration cycle mechanical side. We are working with a 3-ton unit with 410A, R410A. And let's take a look at what kind of pressures and temperatures we're running. Thing to remember is pressures and temperature, they are related. So take a look at our chart here. Temperature pressure chart. On the left side we see the Fahrenheit, and on the right side we see the pressure, and this is for 410A. Why are we interested in the temperature pressure chart? Because we're really interested in what temperature this system is running at. We are interested in what temperature this is changing state in the evaporator. We are interested in the temperature that is changing state in the condenser. That's what lets us know if the system is running normally. It's also interesting to see that on the high side you've got over 400 psi-G, so make sure your system is brazed in nice and tight so that it can handle those pressures. But if you have your temperature pressure chart handy, you can convert these pressures into what their corresponding temperatures are. Now, if you've got a nice expensive gauge set like this one here, a nice digital gauge set, you probably can just press one button and convert these to temperature. Right there. We've got 40 degrees change of state in the evaporator, 120 degrees change of state in the condenser. So let's talk about superheat and subcooling. What do we mean by superheat? Superheat is the temperature that we measure right off the suction line. We're outside at the condenser unit. We have our little meter. We have our multimeter with a temperature probe or some type of way of taking temperature right off the pipe here. This is the larger of the two pipes, and we're going to take a temperature reading, and whatever that temperature is warmer than this temperature here, whatever it is warmer than your evaporator change of state, that is your superheat. It is the heat above the change of state in the evaporator. So I'll go ahead and put a thermometer right there, and we have a 46 degree, we have a 6 degree superheat. I just dropped my temperature. I set my thermostat at 74, the indoor temperature at 75. Let's make our time move faster there. So at these temperatures, I just like fives. At these temperatures, I have a 5 degree superheat with a thermostat set at 74. My indoor temperature is actually 75. I've locked it so that the system will keep running. My outdoor temperature, ambient temp, is 95 degrees, and my relative humidity is 50%. That is a very typical day on a good running system. We have a 5 degree superheat. What is our subcooling? Subcooling, when we take a temperature on the liquid line outside again at the condenser, this is the smaller of the two lines, we're going to take a temperature reading. Whatever that temperature is under this, under the change of state in the condenser, that is your subcooling. So we'll take a thermometer and we'll put it on there, and okay, so now we have, I changed the probe. Probe 2 now is the suction line at 45. Probe 1 is the subcooling, and you can see it. We are subcooling at 15 degrees, 120 degrees change of state minus the temperature we're taking off the line at 105, 15 degrees subcooling, and that's a good normal running system. Let's see some more temperatures. What can we look at? What temperature do you think is blowing outside your condenser unit? 95 degree day, you got your fan running, it's blowing across the coil. Let's see what temperature that is. condenser outlet is 115 degrees. Just 5 degrees under the change of state, and about 20 degrees warmer than the outside temperature. Let's see what our discharge line. Compressor discharge. Right off the compressor, we are kicking out at 170 degree temperature. Condenser inlet is going to be the same temperature as the outdoor temperature. That's 95, 95. Let's see what our supply side. Now if you check across the filter dryer, put a probe on both sides, you get 0 degree difference if this is not clogged. If it is clogged, you will get a difference. Same thing with the metering device. If you check the temperature on both sides, you should have no difference in temperature. Supply air is blowing out of the vent at 55 degrees. If you subtract that temperature from your indoor air temperature, that is what's called your delta T, and in this case you have a 20 degree delta T. That's a very good delta T, again with 50 degree humidity, 75 inside the house, 95 outside. Your return air is going to be the same as your indoor air if everything's running normal. That'll be 75. And that's pretty much the main things to check. Now, question, what will happen to our delta T if we lower the humidity? Do you think the delta T will go up or will it go down? Let's try it. Instead of 50% humidity, let's drop the humidity down to 20%. Let's increase our run time to make some time go by. And look at that. Our supply temperature has actually dropped lower, so now our delta T is greater. And what happened to our superheat? Our superheat is now 39 degrees on the suction line and only 37 degrees in the evaporator, so our superheat is only 2 degrees. So when we drop humidity, we drop superheat. Good to know. So I think that's a pretty good review, just to get pressures and temperatures in your mind of a normal running system. After this, let's create some faults in the system. So you'll be going into a service call and we'll be simulating a problem. The problem might be a variety of things that you would normally see in a system, and let's see what things look like in a system that is not running properly. So remember this lesson, because it's going to be the one to go back to remember what things look like when they are running correctly. I think it's important to have a good idea of what it should look like, and then when you come across the problem, you quickly identify where the problem is and what the possible solutions are. That will be our next thing. Next lesson.